So we're going to find the area between two curves, but now instead of functions of x, your x and y's get mixed up. So sometimes, you know how you could write y equals x squared, and that's a parabola? And it was easy to get the y by itself and have a function. We can write x equals y squared. It's a function of y, but not a function of x. And we just turn our mindset over 90 degrees and do all of the same math, but now we're thinking about working with the y-axis. So right now this is called find the area by partitioning the y-axis. And instead of looking from two x values from A to B, we're looking from two y values from C to D in this case. And we still have the curve above minus curve below, but now the curve above is the one further to the right, and the curve below is the one further to the left. And the idea stays the same. We've just changed our variable of integration. But sometimes a question becomes easier if you think about dealing along the y-axis rather than dealing along the x-axis. So if I was asked this question and only had the skill set that I developed up till now, can you see the blue curve is on the top, the red curve is on the bottom? So I could I could find my intersection and I could do the blue minus the red area thing. The problem is I don't know the equations of the red and the blue graph, but I could rearrange them. Can you see that this line, I could move my 2 over and divide by 2? Would you agree that's the equation of my red line? That's not hard to do. The blue one's a little bit trickier. If I wanted to get y by itself, what would I have to do? I'd have to square root both sides. If I square rooted both sides, I get plus or minus the square root of x. In fact, I'm going to color code this. I'm going to make this bottom part purple and keep the top part blue. The top part, if I square root both sides, it'll be the positive square root that I'd have to move the 1 over. The purple part would be the negative square root, and I'd have 3 different functions I deal with if I'm dealing with functions that are in terms of x. In other words, the y is equal on the other side. But if I keep the x equals, I only have the 2 functions. If I wanted to do this the old way, do you see that you would take your blue graph and minus your red graph and find the integral? Integrating a square root is not hard, but it involves more square roots. So now what we're going to look at is say, well, since I already have them x equals, I could do the same idea and do the graph on the right minus the graph on the left. Can you see that if you went right minus left, the red one is further to the right than the blue graph? If you're ever unsure, if up and down is easier for you, temporarily cheat, turn your page 90 degrees, look at it, oh, and then switch back and you'd be like, I know which one is further right. Intersection points are the same idea. You make them equal, you solve, you get plus or minus 1. Since we solve for y, be careful because you're not used to this as much. These go to your y coordinates, not your x coordinates. I can see some people possibly making that mistake of just doing things they would normally would do and accidentally switching them into the x coordinates because you're used to that. And once you find your y coordinates, then you could find your x coordinates. Now our area, we are now looking from this point to this point because we're dealing with y's. And we're doing the right graph minus the left graph. Or if you turned it, it's still you can still think of it as the upper graph minus the lower graph. But now you're dealing with y values. So now our area is going to go from -1 to 1 of the line minus the parabola. Again, combine our like terms. A couple of things. Why this is nicer than doing what I showed you first with the x's. The first reason it's nicer. Your intersection points would be identical. That wouldn't make a difference. Okay? But in the integration, with the y's, it's simplified to just minus y squared plus 1. Really simple integration, y cubed. With your other ones, it would simplify, but you would have a square root of x, which integrates, gives you another radical. Just as a little bit messier numbers to work with. You would get the same answer in the end either way. You would get 4/3. But in this situation, it made sense to partition the y-axis rather than partitioning the x-axis. In some examples, it is way better to do partitioning the y than the x. In this example, this blue part is further to the right. This green part is further to the left. So if we partition the y, which we're going to do, it's just going to be blue minus green. But let's say on the exam, you were like not thinking of partitioning y, or for whatever reason, this lesson was gone from your memory completely. And you only had partitioning the x. So can you see that you would have, if you got x by itself, you would have the following purple part and blue part as separate equations. Then you do upper minus lower. So this part of your graph, which I'm going to color in in orange. This part you could do the green minus the blue. This part you could just figure what was under the purple. And this part you could figure out what was under the blue, but you would come out negative and you'd have to make it positive. There's a lot more work that would need to be done if we did this partitioning the x-axis. First of all, we'd have to get our equations by themselves. Somewhat problematic, but not the end of the world. Then you'd have to figure out the orange area, the purple area, and the blue area separately. But partitioning the y, we can do this all at once. We find our intersection points at 1 and -2. Sorry. Yeah, because now -2, again, right? You're thinking of your y values, not your x values. Again, that would be an easy thing to mess up on this type of question. So I'm going from -2 to 1. The one on the right is the parabola, minus the line is the one on the left. I can combine some like terms here. And I get my area a lot quicker. Number one hints that are saying that it's better to partition your y than your x. is they give you the equations and they're x equals already. They're in terms of y. That's sort of the number one way to say, I think I should do this. Sometimes they don't. Sometimes they'll give you, I've seen on the exam, they'll give you one as x equals and the other one, right, I moved my one over. The other one they give you is y equals, and they're sort of like, ooh, I either have to make them both y equals or both x equals. Then look at the graph and decide which one will be easier for you to partition. Is it easier to break it up using up and down x-axis? In this case, absolutely not. 3 different areas you'd have to figure out. Or is it easier to do right minus left?
Oh my god. Let's look at the next page.
This one?
Oh, page 15.
Oh yeah, we start rotating. I notice it.
I don't want to do that.
It's so much. Oh, it's so cool. Okay. I'm going to do this one. Here, this is, did I not lead into this? The question gives us one thing as y equals, and the other one is x equals. So I'm like, I have the option. I can partition my x-axis. I can partition my y-axis. If I partition my x-axis, I'd have to get all my y's by itself. So I move the 9 over, I move my y squared by itself, I square root. And now I have y minus 9 minus 9x and y equals 9 minus x. I should color code these. So this one in blue, oh, color coded. Sorry. That graph is already in red. I will highlight the red graph with a red part. That's this part right here. I'm going to highlight this. No, I'm going to highlight this in purple. And I'm going to put this in blue because the whole parabola, the whole horizontal parabola is already drawn. The purple part is the positive part. That's that section. Because if I would square root both sides to get y by itself, I would have plus or minus. Yes.
Are we partitioning by the x-axis first? Or
Yeah,
the
it
y-axis?
says partitioning the x-axis first.
So shouldn't we isolate for? Oh, that's what we did.
That's what we did. Shouldn't we isolate for y? Absolutely.
It's early in the morning.
But it feels weird when you say partitioning the x-axis and then you get your equations y equals, the variables switch on you like that. Can be common. So now I want to find that purple shaded area. How am I going to do that? Can I just do the purple minus the red? It's a little bit problematic because the red stops at 1. Okay? So I could do the purple minus the red from 0 to 1, and that would give me this little area in here, right? And then I would just have to do the purple from 1 to 9. So I do the purple minus the red from 0 to 1. And then from 1 to 9, I just have to go underneath the purple. So in this example, partitioning the x-axis, we had to do the integral in 2 different parts, just by the layout of the graphs. But we could do the math, blah, blah, blah. I feel like if I were you and I was copying down notes, I would copy down this for sure, because that's the idea. And then I would say, I know that you can do the math. Trust yourself and just write down that it should be 16. Okay. Do you trust yourself you could do that math? No. Be more trusting. If you don't trust yourself, do that on your own, and you'll get 16. Then you probably made a little mistake. What are the little mistakes that I see you doing here? The little mistakes I see people doing. I think you have no problem, this is to the half, right? I think you'd have no problem adding 1 to the exponent and dividing by the 3/2, which is the 2/3 out in front. Could I see you forgetting the chain rule that there's a negative in front and forgetting this negative? Yes. I could see that. And that happens in, well, and in the second one, you'd add 1 to the half to get 3/2, divide by 3/2. Like personally, if I was doing this integral, I would have first changed this. Right? This is for me, how I like to show work. I would change that to the half. I like to show that. I'd add 1 to the exponent. And I like dividing by the same exponent instead of doing the, like I did the flip right away. Okay, what also does this one have? This one has a chain rule where I would have, if I was doing the derivative, I would multiply by -9. I like to show the -9, just like -9/1 on the bottom. And so do you see that I would get -27/2? Dividing by a fraction is the same as multiplying by the reciprocal. But if I was doing an answer key, I'd definitely show all of these steps. Part of the reason they're not shown in your notes, because you guys are AP students. If I click open a box, and there was math that made no sense, but lots of, you would all write it down. That's how you are, right? Like if I click open a box, you are like, I have to write this up. So sometimes we don't show our work because we're like, we know that if we showed more work, you would write it all down. And it would waste as much time as me explaining it to you right now. It's wasting time. Yes. Where does this 2/3 come from?
No, I'm just saying over there, you have the little, like, on the right, above the green thing.
Oh, that's the math showing, I knew people would ask about this. So we showed this. Did you write that down?
No.
No, okay, some of you got this. I'll let you know. Okay. So tomorrow we'll look at partitioning in the Y for this same thing.
Here it